In this video, I'm going to look at some shortcuts that exist in the, well, in this case, it's the TI-84 plus Silver Edition virtual calculator I'm using here. I think you could also find some of these on the 83, but if you try the procedure I'm using here and you don't see those menus, then it's probably not included on your calculator. But this is the 84 Silver Edition, and basically I'll be using the F1 keys in the calculator, in particular F1, F2, F3, and F4. These will be problems involving algebra and calculus. So we need to hit the alpha key to get these menus. So hit the alpha key, and then here's F1 right there above the y equals here. So I go into that, and this one just deals with fractions. Changing a fraction into a mixed number, or changing a fraction to a decimal, and vice versa. So I'm going to go to the next one, hit alpha again, and F2. And the first one is absolute value, so that's pretty basic, but we'll go ahead and do that. So I'm going to hit enter there, and then enter some number. Let me do this here. So I'm going to do the F2. So I'll do the F2, hit the alpha key. And the first one's absolute value, pretty straightforward, but I'll hit enter to access number 1 there. And you just enter any number, say -9. So the absolute value of a negative is always a positive. The absolute value of 0 is always 0. So in this case, absolute value of -9 would be, of course, the opposite of -9, which is 9. There you have it. Okay, so let's go back to that one again. Alpha, and then F2. And this number 2 is for sequences. So let's go ahead and hit enter, or hit number 2 rather, to get that one. And then you have to enter the limits. And you can pick any variable you want here. So I'm going to use x, so x, and that goes there. And we're just going to go from 1 to 100. So put a 1 there, and then up, 1, 0, 0. You have it. And then go over. Now I need a function right here. Since I'm using x equal 1 to 100, then I want this to be in terms of x, so I can have something like x squared plus 1, or whatever you want. There's a formula. Just to keep it basic here, I'm going to hit x. So basically what we're doing is we're letting x equal 1, and then x equal 2, x equal 3, and so on. So basically we're adding the consecutive counting numbers, or natural numbers, from 1 to 100. So basically it's 1 plus 2 plus 3, plus 4, plus 5, plus 6, so on, all the way up to 100. So if I hit enter, I'll get that sum. And there it is, 5,050. Okay, 5,050. Let's clear this. Go back to that menu again, alpha, and then F2. Now I'm going to use number 3 here is the nth derivative. Okay, so this is calculus. Okay, so I want the nth derivative, the second derivative, third derivative, whatever. Okay, so I'll hit number 3. And then again, I want to pick the variable usually it's going to be x, so pick x here. And this is just going to be the first derivative here. X. And enter what I'm taking the derivative of. Okay, so I'm going to enter, say, 4x to the 3rd power. Okay, now this calculator doesn't give you symbolic answers. Okay, so answers in terms of a variable x in this case. Okay, so you're using, say, a TI-89. The TI-89, if you just compute the derivative of 4x to the 3rd, it'll come out to 12x squared. That's the derivative. 12x to the second. But here what we're getting is we're finding the derivative at a certain value of x. So we're saying, what is the derivative of 4x to the third? Evaluate it at some number. Okay, so what number do we want to pick here? Anything you want here? I'm going to pick 2. Okay, so again, remember the derivative is 12x to the second, and then we're evaluating at 2. So 4 times 12 is 48, so we enter here, and there it is. Now again, it's exactly 48. Get the calculator again. The formula it's using comes out to 48.000 and so on out to 4, but it's really just 48. Okay. The TI-84 would give you exactly 48 if you're computing the derivative of 4x to the third at x equal to 12. Okay, so let's clear this. And let's go to that one again, the second one, F2. So now I'm going to go to number 4, and this is the integral. Okay, so if I hit 4 here, again, this is calculus. So the integral, again, we need limits. Okay, so I'm going to start from 0 to 2, and then I need a function there that I want to integrate. So instead of I'm doing just the opposite of the derivative. So I want the antiderivative, or the integral, evaluated from 0 to 2. Okay, so the function I'm going to use is going to be x to the second. And then here in this blank right here, I have to indicate the variable I'm using, so it's going to be x. Okay, so basically, by doing this computation, basically what we're doing, okay, let's say this is the coordinate system, the y-axis and the x-axis, and let's say I have a parabola. And it doesn't look like a parabola, so let me do it again here. Let me just draw it like this, and it goes up. Okay, a little sloppy here, but that's what we're doing here. When we put these limits 0 to 2, so we're going from 0 to 2. So if I go, let's say right here, let's say this is 2 here. What we're computing is the area that's bounded by the curve and the x-axis. So it's this area right in here. Okay. So if I hit enter here, it comes out to 2.66, or we can run this out to 2.7. 2.7. Okay. So that's the antiderivative, or the integral, using this shortcut. And I want to point out to you that there's other ways to do it here in this calculator, but these are just the method using the F1, F2, F3, and F4 keys. So we'll clear this here. And let's go to the alpha again. Alpha 2, now let's look at number 5. Okay, so you've heard of taking the log of a number to base 10, or base e, which is the natural log. And of course, you can have any base you want here. So in this case, we're going to compute the log of some number to base. Again, the base, remember, has to be greater than 1 or not equal to 1, and has to be positive. So I'm just going to pick 2. And then I'm going to pick a number here that has an exact answer. Okay. To base 2, by definition, what we're asking for is 2 to what power is 32. Okay. So if I hit enter, the answer is 5. 2 to the 5th power is 32. Okay. So that's what that gives me right there. So you can compute using this shortcut here, then you can compute the log of any number to any base you want, as long as the base is not equal to 1 and positive. The base cannot be negative, and not equal to, it can't be equal to 1, and the number you're taking the log of has to be positive. Okay, can't be 0 or can't be negative. So let's clear this here. Let's look at alpha and F3. Now this one deals with matrices. You see here highlighted MTRX. It's a matrix. Okay, so here you enter the number of rows, the number of columns. So you have 2 rows, 3 columns, and it's a 2 by 3 matrix. And remember that every matrix has a number associated with it, which is called a determinant. Okay, so let's suppose we wanted to find the determinant of a 2 by 2 matrix. It has to be square. Okay, only square matrices have determinants associated with them. Okay, so the number of rows has to be the same as the number of columns. Now, before I do this, here I can generate the matrix, but in order to find the derivative, I got to go to the matrix section. Okay, so this is another way we could do this, but the only thing I'm going to do here, though, is go to math. Okay, so here's matrix. Here's one defined by a 2 by 2. So I could also work the problem using this menu here, but I'm just going to go to math here, and I'm going to select number 1, which is determinant. Hit enter. Okay, so now what I'm going to do is I'm going to put a matrix here and then take the determinant of that. Okay, so now I'll go to alpha 3, and I want a 2 by 2, so I want 2, hit enter, and then number of rows is 2, the number of columns is also 2, so hit enter, and then OK. Okay, there it is. Okay, so it gives it to me with zeros, and I can fill it with any numbers I want. So let's put, say, 3, then -2 in that first row, then the second row, a 6, and a 1. And then close parentheses. It might give you the answer without the parentheses, but usually we close it, so I'll put parentheses there, and then I'll hit enter. So this tells me the determinant of this 2 by 2 matrix that has components 3, -2, 6, and 1 is 15. Okay, so that's one way you can compute the derivative of any square matrix. Okay, again, number of rows has to be the same as the number of columns. So let's clear this out. Now, associated with a matrix, a square matrix that does not have a determinant of 0, we have an inverse. Okay, just like 2, the multiplicative inverse of 2 would be 1/2. 2 times 1/2 gives me the identity element 1. 3 has a multiplicative inverse of 1/3. 3 times 1/3 is 1. That's your identity. Okay, so we have the same sort of thing with matrices. So let's suppose I want to generate the multiplicative inverse of a matrix. Okay, so again, alpha. Again, I want a 2 by 2, so 2, number of rows, enter, number of columns, 2, and then OK. Okay, so let's suppose I want the multiplicative inverse of this matrix here. First row is 3, and 1. Second row has components of 2 over 1. Okay, so now to get the multiplicative inverse, I would go to right here next to the sign function, or I can just take it to the -1 power, but let's do it this way. There it is. So if I hit enter, this will give me the multiplicative inverse. And I get 1, -1, -2, and 3. Okay, so this would say if this were a 2, this were 2, then 2 to the negative 1 is 1/2, okay? So if I multiply this matrix here, just the matrix 3, 1, 2, 1 times this matrix right here, I should get the identity matrix, okay? So let's set it up this way, okay? So I'm going to multiply this matrix in the next problem. I'm going to multiply this matrix right here, which is the inverse, multiplicative inverse, by the matrix right here, 3, 1, 2, 1. Okay, so let me just clear this. And let's do it this way, alpha. Okay, so again, same thing. 2, down, 2, enter, and then down, and then enter. And then, okay, so the matrix that I want is going to be 3. Okay, so same one that I had a while ago. 3, 1, and then 2, 1, and so on. Now, if I multiply this by the multiplicative inverse that I just got previously, I should get the identity matrix. Okay, so again, go alpha. Same thing again. So this will be 2 for the number of rows, hit enter. 2 for the number of columns, hit enter. And then OK. And then just fill it in. So now I'm going to multiply these, but I want to fill in the values that I just showed you in the previous solution. So this will be 1, negative 1, negative 2, and then over to the next position, and 3. And then if I hit enter, these two get multiplied using the rules for matrix multiplication. So hit enter. Okay, this is your identity matrix. Any identity matrix has ones along this diagonal right here and 0 everywhere else. Okay, so there you have it. Now, let's clear this here. Let's go to F4. So again, we have shortcuts. F1 deals with basically arithmetic fractions, and then we have F2, F3. And let's look at F4 here. F4 has these variables, Y1, Y2, Y3, Y4, Y5. So okay, let's hit enter and I access Y1, Y sub 1. Hit enter, okay. So what can I do with this? Well, one thing you can do is you can evaluate a function. So if I put parentheses there and enter, okay, I want to evaluate this function at 2. So I enter, say 2 on any number you want, and hit enter. So it tells me the value of this function y1 is 8. Okay, so where does that come from? Well, it comes from whatever you selected over here in your graphing menu. Okay, so I selected the function y1 to be 2x squared, and I could make this anything I wanted to. Okay, I could have a polynomial there with 20 terms, and you can easily evaluate it by just using that procedure. Okay, so here's the way the calculator said, okay, if you want y1 evaluated at 2, this will be 2 squared. And I want to apologize for my voice, but that's the way it is sometimes. Laryngitis a little bit. So put 2 there. That's 2 squared is 4 times 2 gives me 8. Okay, that's how I got it. Okay, and you can continue to do that. You want y1 again, you can do it again. Alpha. Let's do again y1. So y1. Let's say we want to evaluate this at -2, or let's say -6. close the parentheses, hit enter, and there you have it. Okay, let's suppose we want to pick one of the other ones there. Okay, let's say the second one, so hit a 2 here. Or let's just do it this way. Okay, select it, enter. Okay, so I could put parentheses here and then say put a 2 here, hit enter. And it gives me an error because I haven't defined what y2 is, okay? So in order to do that, you have to go to your graphing screen and say what it is. X to the third minus x squared or whatever you want, okay? But anyway, these are just some shortcuts that you can use in algebra and calculus if you're looking for numerical answers. Thanks for watching. We'll see you next time.